5-6 day 2, triangle area and Heron's formula. Here we have a standard triangle that's labeled with the appropriate letters, and the angle and the sides that are labeled A are across from each other, and likewise with the other letters. Let's draw a height. And we are interested in finding the area. Well, the area of a triangle is 1/2 base times height, where this B and this B are not necessarily the same thing. They could be. But in this case, our base is C with the way that I've drawn the height. So A equals 1/2 times C. And then we could find the height. We found the base. That's C. We need to find the height. We could do the sine of B equals H over A. So H equals A sine of B. So this is A sine of B. Now we could, that's the formula right there. Now if we're going to use angle C, it'd be 1/2 A times B sine of C. So it's the sine of the angle and the included sides. Or we could have 1/2 of, if we're using angle A, then it would be sides B and C. Example 1, find the area of a triangular lot having two sides of length 90 meters and 52 meters respectively, and an included angle of 102 degrees. So let's draw something that represents 102 degrees. Let's say this right here, 102. And the included sides are 52, and if I make this one 90, maybe it's way over here, 90. So this is the third side. And find the area of the triangular lot. Well, the area equals 1/2 times 52 times 90. Those are the included sides of the angle I'm using, times the sine of 102 degrees. So if we take 0.5 on our calculator times 52 times 90, that should say 90, not 9, times the sine of 102, we get 2,288.865, and that would be meters squared. Heron's formula, given sides A, B, and C, the formula is the square root of S, which stands for semi-perimeter. Now the semi-perimeter of a triangle is all three sides added up, and then you divide by 2, kind of like a semicircle. That would be half a circle. So here is the semi-perimeter. And then it's S times S minus A times S minus B times S minus C. So here we have an example. In example 2, the area equals, well, let's find the semi-perimeter first. Semi-perimeter equals 13 plus 15 plus 18, which is 46. Divide that by 2, 23. The semi-perimeter is 23, so the area of the triangle is the square root of 23 times 23 minus 13, 3, 23 minus 15 times 23 minus 18. So on our calculator, we're going to take the square root of 23 times 10 times 8 times 5. And the answer is 95.917 units squared. Discuss included angle. If I told you that two sides were 24 and 30 inches, let's say, and the included angle is 43 degrees, that would mean, let's say this would be 24. If I made this one 30, here's the included angle in those two sides. That would be 43 degrees. Now if it says angle and included sides, then it's just the opposite of that. If I said that the angle was 34 degrees and the included sides were 25 and 31, then this could right here, that could be the 34 degrees, and the included sides of that angle would be, this could be 25 and this could be 31. In triangle ABC, given A is 11, angle A is 82 degrees and angle B is 63 degrees, find the area. So I need an 82 degree angle and a 63 degree angle. So let's say this is 82 and this is 63 degrees. Here's the 82, here's the 63. Now that's angle A, this is angle B, so this is angle C. They tell us that side A is 11, so that puts that there. And in order to find the area, I need to find C, because then you'd have the angle and its included sides in the area equals 1/2 times 11 times whatever value C is times the sine of 63 degrees. So I need that value right there. Well, we can use law of sines to find that. 11 over sine of 82 equals, I can find that angle. If I take 180 on the calculator, minus 82 minus 63, that angle up top, C, is 35 degrees. So we have C over the sine of 35. 11 times sine of 35 divided by sine of 82 gives me 6.371. 6.371. Of course, I still have that in my calculator. So I'll take 0.5 times 11 times the answer, and then times sine of 63. Enter. The area of the triangle equals 31.223 units squared. In triangle ABC, given A is 13, B is 9, and C is 73 degrees, find C. 73 degrees. That's pretty steep. Let's say it's about there, and this would be maybe the other side. So we have an angle of 73 degrees. This may be the 13, and this is the 9. This is C. The 13 is A, so this must be A up here and B down here. So we have, they want me to find side C. So C squared equals 9 squared plus 13 squared minus 2 times 9 times 13 times the cosine of 73 degrees. We need to use law of cosines here when you have an angle and its included sides. So on the calculator, I'll take 9 squared plus 13 squared minus 2 times 9 times 13 times the cosine of 73, and I get 181.585, and then we take the square root of the answer, and we get C is 13.475. Determine the number of possible triangles that could exist. In the first one, we have an angle of 128 degrees. So let's say that is 128. And I'm going to draw it like that in case we don't have a triangle. So here is 128 degrees. That is angle A, so side A is 30, and this would be angle B if we connected them. And over here would be 40. Now this is not long enough to get back down to the bottom, so we have 0 triangles. In the next one, we have an angle of 34 degrees. Let's say it's about there. And this is the ambiguous case, so I'll just drop it right there. Actually, it's going to be longer than the other one. So let's pretend there is a triangle. We'll find out in a second here. This is the 34 degrees, and that's angle A. So A is over here 28, and this is 25. Now, since this one is longer than this one, when we swing around here, it's going to swing all the way. It will form another triangle, but that doesn't count because you'd have to change the angle of A. So this is one triangle. In the last example on this page, we have a 30-degree angle. This is 30. It's angle C. This is 14. And if we call this angle A, because that's the remaining measurement is side A. This is 39. Well, let's find the height, and we'll compare that to 14. So we have the sine of 30 equals h over 39, opposite over hypotenuse. This is h. So we have 39 times, the sine of 30 is a half. So h equals 18 and a half. Well, that's 18 and a half, and if this is only 14, it's not going to be able to reach down to the bottom. So this is 0 triangles. On the last one, this is 2 triangles. We'll talk about why that is. A little bit of review here. Let's call that 52 degrees. This is 11. And if that's 11, then, let's see. Maybe I should move it over here. That has to be a little longer. There's 11, and this would be 9. So here we have the 52 degree angle, which is angle B. This is 9, and this is 11. Well, if we draw, or if we calculate the height, the sine of 52 equals h over 11. So to find the height, I need 11 times the sine of 52, which is 8.67, let's say. 8.67. 9 will reach the ground, and as a matter of fact, it'll swing over here, and we'll end up with 2 triangles. Let's solve the first triangle. B is 52 degrees. A is 11, and B is 9. Our first step is to, what are we going to do here? We can solve for 11 is the A. We can solve for A. We have 9 over the sine of 52 equals 11 over the sine of A. So 11 times sine of 52, we'll divide that by 9, take the inverse sine of that answer, and A is 74.392. Now if I add 52 to that, subtract it from 180, C is 53.608. Now we have to do the law of sines one more time to find C. So I have C over the sine of 53.608 equals 9 over the sine of 52, and I just barely made it. So we have 9 times the sine of the answer divided by sine of 52. So we get 9.194, rounded to 3 decimal places. Now, when we swing this one over, we get another triangle that has the same criteria, and it's this skinny little triangle right here. So A is acute for this triangle, and now A is going to be obtuse. So here's A1, here's A2. These two are supplementary. So when we have A2, B2, C2, A2, B2, C2, B has to be 52 still. This still has to be 11. This still has to be 9. Now this A up here and this A are supplements of each other. So I'll take 180 minus 74.392. And we get 105.608. Now if I add 52 to that, subtract it from 180, I get 22.392 degrees. So there's all the angles, and now I'll have to use law of sines one time with a rounded answer. That's not too big of a deal to finish this out. So we have the C over the sine of 22.392 equals 9 over the sine of 52. So we have 9 times sine of 22.392 divided by sine of 52. So this is 4.351.